Hello everyone. Today I want to present a topic on traffic signal control around the world. And this is the second part of my presentation, and this comprises with control logic, traffic control logic, sensor used in the traffic control, safety standards regarding intersections. I am Saurabh Borua, a PhD student, Chulalongkorn University. So firstly, look at the purpose of traffic signal, because unsignalized control where there is no signals, traffic is light and vehicle speed are low, and pedestrian are also very low. In that case, we can use uncontrolled signal intersection where there is no signal. But in the signalized intersection, we need traffic signals where traffic volume is high, speed is more, and overall traffic scenario is much more complex. So we need traffic signals because high volume or high vehicle density, the speed of vehicles are increased, and turning movements are much more complex, and there are heavy pedestrian activity. So we have to manage conflicting movement firstly. Secondly, we have to reduce crashes. And thirdly, we have to improve and protect pedestrian. So safety is also a concern for traffic signal. So these are the purpose. So let's compare and talk about the basic concepts. We can see that the traffic volume from low to medium to high traffic. We can see that in the low volume traffic, we can use four-way stop sign. It is simple and much depends on driver reliance. No need any power and it is low cost. But when traffic volume is high, we need power control device to regulate and control vehicles. We cannot rely on the driver in that case, and higher capacity will be ensured in those signalized intersection. Sometimes we need program logic. Obviously, we need program logic for signalized intersection. That program will be based on cycle time and detectors. We may use detectors, and obviously it associated with high initial cost and maintenance cost as well. And what is the benefit of traffic signal? Firstly, it provides uniform traffic control and reduce ambiguity where traffic volume is high, speed is high. And also we have to maintain some national standard. For example, in US, they have MUTCD, which is a national standard for designing, installing, operating traffic control devices. So to make a standardized traffic control, traffic signal can ensure this opportunity. And MUTCD is the rule book in US standard, that is manual on uniform traffic control device. And it defines standards for traffic signal signs marking and warrants where signal is justified, where traffic volume is a factor, crash history, there are crash history. And obviously it will be based on data-driven criteria, safety decision, and data-driven decision will have to be ensured. And we have to ensure the consistency. That's why we need some sort of manuals which will be appropriate and consistent across all types of road. And standard will be based on highways, rural, urban streets, and each different categories of road should have different type of course and their rule regulations, which will be written in the manual. Then comes about the isolated intersection, which is standalone, mostly used in the rural roads or highways, but also possible in the urban streets. And these are fixed time and can be actuated. Low traffic volume is commonly seen and geographically separated from other signalized intersection. And local maintenance and simple traffic signal plan operation is observed for the isolated intersections. However, in the urban roads, we use coordinated signals. In the rural and highways, the challenges faced is it reduces traffic efficiency, driver frustration, because sometimes it is low traffic and there is no traffic in one direction, but red signal is raised. Also, there can be a tendency to increase accident risk due to rear end or T-bone collision occurred due to sudden stop by the signals, and there is no real-time adjustment, so it's a problem for the isolated intersection. So potential solution can be we can introduce advanced sensor adaptive control, localized AI, or network-wise upgradation can also be possible. Then comes the control logic. Control logic is the brain. So in the fixed time, we have fixed time and schedule historical traffic data. Those are getting into as input, and real-time traffic sensors such as vehicle detection, traffic flow, congestion level also get informed. And this logic works sequencing and decision-making algorithm also ensure the safety protocols, then select the decision logic, then output will be in each approach wise, it will assign green phase, yellow transition, and red phase. So our key benefit will be maximize efficiency, ensure safety, dynamic adjustment for traffic, and responsive to pedestrian. Then comes the sensor. Sensor are the eye of the system. So sensor can be, there can be 2 sensor system, 4 sensor, or 8 sensors, and it will be placed in each approach to feed data into the control logic. And mostly they use to count presence of vehicle, or also can measure the speed gap, utilize the gap and distance information. We can see the sensors located in the in a intersection of a different of its different approaches. Then comes the sensor data. Sensor data use presence of vehicle. We know it can identify waiting vehicles, then it can count vehicles. Through counting, we can get traffic volume. Then speed sensors can measure speed, and distance and gap sensors ensure spacing and safety related information for traffic, and those data are feed into the adaptive control system, and then decision are made based on the real traffic scenario. Then comes the smart traffic control and sensor placing strategies. It optimizes sensor placement. We need to optimize sensor placement and upstream positioning. Consider the upstream positioning of sensor to detect the traffic flow, then place the place where to place. It can be short or in the stop bar or in the for the advanced warning. What type of information we need sensor that is a main issue. That further distance offer more advanced warning for control logic. So control logic and location and placement of sensor is important here. So to enable proactive adjustment, green wave optimization, traffic forecasting, and emergency vehicle preemption, we need sensor data transmission, control logic, and real-time signals to feed into those information. It will detect the cues, and also advanced warning system can also get information to feed into the signals. Then semi-actuated traffic signal control, if we look at that, where there is a major road and minor road, in the minor road only have sensor to detect vehicle, and logic is triggering green light. However, in the major road, green is default, which is high priority. When vehicle detects certain amount of delay or maximum amount of delay in the minor road, then it turns green in the minor road and turns red to the major road. So with semi actuation, the major road has continuous flow. Without actuation, major road has to stop due to minor traffic. So this is the problem. Also, fuel consumption, unnecessary stops in the major road will be increased without semi-actuated traffic signal. Let's see the comparison of traffic signal controller. We have fixed time traffic signal, semi-actuated traffic signal, and fully actuated traffic signals. Fixed time traffic signals, its phase, cycle length, green split is fixed, and sequencing is also fixed. So it may cause unnecessary delay during light traffic and congestion during heavy traffic. Semi-actuated traffic signal, it gives priority to the major road and especially the one approach, and reduce delay in the main road, and maintain minimum green time for the minor or side road. Fully actuated traffic control is possible where we have sensor in all roads. It maximize overall efficiency of the intersection, adjust green time dynamically, and maximize the flow. Next comes the topic about the estimating arrival time and extending green, vehicle detection and logic. That control logic uses sensors and real-time speed and position are measured. Then real-time, based on that, detect the approach and lane occupancy. Then arrival time will be estimated, that when the vehicle will come to the intersection. Based using that information or calculating that information using mathematical formula, we can adjust the signal, and green time can extend it, and dynamically green time can extend it, and it prevents the stop. So its advantage is it reduces unnecessary stops, improves delay and safety as well. So if we look at the cost of stopping and power extension, we can power of extension, we can see that the stopping harms and extends green, ensure pass without stopping. So cost of stopping, if we have frequent stop, then waiting time will increase. Head-on rear-end collision, risk of rear-end collision will be increased, and there is also emission and fuel wastage. Emission will be more and fuel wastage will occur. And power of green extension, if we can extend the green, then it will ensure smooth traffic, reduce delay, lower risk of rear-end collision, and less fuel consumption, ensure clean air indirectly. And let's now talk about the dilemma zone, which is related with yellow interval. And dilemma zone is the zone near the intersection where drivers are not sure or face confusion near a stop line where to stop. Neither safely stop nor safely clear. So the position of driver can neither safely stop nor safely clear. So to tackle the dilemma zone and mismatch, we ensure at least 4 seconds, sometimes use 3 seconds. We ensure calculate green interval. And it's not flat actually, green interval, not yellow interval. The yellow interval is related with the vehicle speed on the approach, and yellow timing is required because it can minimize dilemma zone, because if the dilemma zone is long, it's not safe for drive vehicle, and reduce rear end collision and prevent red light turning and calibrate vehicle performance as well. So benefit of optimized timing for using yellow light is dilemma zone incidents will be reduced, red light running event will be reduced, and safety level will ensure maximize safety and frequency of stopping at intersection will be reduced. Then comes the all red interval to clear. So in the incoming approach, we use yellow or red. So cross street waits green and main street clear in the red or yellow. But when we use all red clearance interval, it can be 1 to 3 seconds. All approach should show red and allows intersection to clear completely. So after the all red, one phase will show green and traffic can proceed in one crossroad. It protects against clearing vehicle. Which vehicle cannot pass in the yellow phase, it protects those vehicle, and if there is a tendency of T-bone collision, it reduces, and overall intersection safety ensured, because this already is a buffer for traffic safety, and especially for high speed minor road crossing, it ensures the vehicle clearance. So the safety is one of the core issue of signal timing strategies. We have to assign yellow signal timing, and so that our dilemma zone will be reduced and decision zone will be increased, and all red clearance interval has to be provided, so that it protect lagging vehicles from previous greens and ensure overall full clearing. Then signal actuation with logic. We have to use detectors, and detectors will be connected with the vehicles, which will be demand responsive. So overall, all these things ensure us higher efficiency and lower total wait time, minimize delay. We have to buffer less while driving and reduce conflict and its risk. So safety first, so to ensure balancing with the delay, because we have to assign yellow and all red, except small amount of it, so that maximize safety. So overall, human life and safety is also concerned with the intersection delay. If we look at the global comparison, the best part is the sensor density and actuation prevalence. We can see in the high density and actuation, we can see in the Singapore, Netherlands, US, but low density and actuation, we can see part of India and Brazil. Also, traffic control codes and standard, USA has MUTCD, manual for urban transport coordination device, and it's followed by USA and Canada, and other national code have Europe, Japan, China has separate national code, and those standard will be followed through the manuals and code book. Urban versus highway intersection philosophy. For the urban intersection, we have to ensure throughput, safety ensure, also adaptive management, manage congestion, and multimodal priority is a concern. But for highway and rural intersection, safety and flow efficiency we have to consider. And best part is that longer clearance speed management and longer clearance predictability you have to take into account for highway and rural intersection. We can see a case study for real isolated intersection control system. where we can see that the stop bar presence and traffic signal head and detectors which can recall minor road approach and the major road. We can see that it will feed into the actuation logic where sensors are located in the major and minor streets, and pedestrian push button is also ensures it will make gap timing for major road. Minimum green will be ensured to the major road, and EU clearance and maximum green limits are assigned. Yellow will be changed to red clearance, and lastly signal state or the output will be signal green signal will be given to minor road or major road, keeping a minor road green, major road hold on using yellow and red. So we can see that the minimum green time, major road sometimes you 10 to 15 second, and red clearance are given 1 to 2 second. For passage time or vehicle extension, it can be 10 to 15 second. And for minor approach, the maximum green time sometimes given 60 to 120 second, and yellow change interval usually given 3 to 5 second. It ensures allowing stopping and entering intersection before all red. We can see the timing rationale applied of a signalized intersection. This is the best part of this slide. Then comes the takeaway of this study. We can see that the traffic signal control replaces judgment of drivers, and stop sign judgment versus program logic. Sensors enable real-time data, and loop detectors, video detectors, or real-time vehicle count can be possible, and it will feed into the database to feed in to get control logic. Timing decision resolve safety risks. We have to think about the dilemma zone. Yellow interval, all red clearance, solves stop and go decision and intersection occupancy. Green, we can ensure green extension. Through using green extension, we can resolve rear end risk, not resolve, we can reduce rear end risk. And for every timing decision, yellow interval, all red, green extension we can consider, and overall it will ensure safety parameters, vehicle clearance, and collision prevention we can ensure. So that's it all about. Thank you so much for watching my presentation. That's it today about my presentation.